Hello students, welcome to MAGESH classes. In this presentation we are going to discuss about plus 2 electrochemistry, 1 mark questions from 1 to 25 with the detailed explanations. It's the third video we have uploaded in electrochemistry. If you are new to this channel, don't forget to subscribe for more videos and click the bell icon for immediate notification. Let us move into the question part. Question number 1. The number of electrons that have a total charge of 9650 coulombs is. The concept is, so we have known that 1 Faraday is equal to 96500 coulombs. That means it is the charge of 1 mole of electrons, or this is equal to charge of 6.023 into 10 to the power 23 electrons. That means in 96,500 coulombs, the number of electrons are 6.023 into 10 to the power 23. Here, so the number of electrons present in the 96500 coulombs is 6.023 into 10 to the power 23. Here the question is number of electrons present in the how many coulombs, that is 9650 coulombs. By cancelling this, you get 6.023 into 10 to the power 22 electrons. So the answer is C. Second question, consider the following opposite reactions. Mn2 plus 2 electron gives Mn. The EMF of the reaction is minus 1.18 volt. The second one, Mn2 plus gives Mn3 plus electron. E0 value is minus 1.51 volt. The E0 for the reaction, that is 3 Mn2 plus gives Mn plus 2 Mn3 plus, and the possibility of the forward reactions are respectively. So you have to find out the E0 value and whether the reaction is spontaneous or non-spontaneous. The concept is del G is equal to minus NF E0. Del G is negative, or you may say, or E0 is equal to positive value. The reaction is spontaneous. Del G is negative or the E0 value is positive. Here we have to calculate the E value. The required equation is 3. The given equations are, the first one is Mn2 plus 2 electron gives Mn. Here the E0 value is minus 1.18 volt. Okay. The second one, here the required equation consists of 3 Mn2 plus on the left hand side. Here, so you have to multiply this equation by 2. Okay. So it is 2 Mn2, 2 Mn3 and 2 electron. The E0 value is minus 1.51 volt. By adding this, what you get? You get 3 Mn2 plus gives, here the 2 electron is cancelled, you get Mn only, so Mn plus 2 Mn3 plus, this is cancelled. Here the value is, by adding you get, it is E0 is equal to minus 2.69 volt. Here the E0 value is negative, so the reaction is non-spontaneous. Okay. Here the non-spontaneous is given in the 2 option, so the option is B. Clear? Question number 3. The button cell used in watches function as follows. Zinc solid, silver oxide solid, water liquid, 2 Ag plus zinc 2 plus 2 OH minus aqueous. E0 is equal to 0.76 volt. The half cell potentials are silver oxide, water and electron, 2 Ag plus 2 OH. E0 value is 0.34 volt. The cell potential will be, what is the concept? That is E cell. E cell is equal to E0 oxidation plus E0 reduction. Here the cell potential is. Here the zinc is oxidized to zinc 2 plus. It is zinc 2 plus. Here the zinc. So this reaction is oxidation reaction. So the oxidation potential, that is oxidation, is equal to 0.76 volt. In the second one, here the silver oxide is reduced into silver. The oxidation of silver is here +1, here 0. So it is reduction. So E naught reduction is equal to 0.34 volt. E cell is equal to E oxidation plus E reduction. So it is 0.76 oxidation and reduction 0.3 volt. This is equal to 1.10 volt. Your answer is C. The cell potential is the sum of the E oxidation and reduction. Here the two reactions given. One is the oxidation. Here the zinc oxidation state is 0. Oxidation state is +2. So it is oxidation. So it is oxidation potential. And this it is a reduction potential. By adding you get answer. Clear? Question number 4. The molar conductivity of a 0.5 mole decimeter inverse solution of silver nitrate with the electrolytic conductivity of 5.76 into 10 power minus 3 Siemens centimeter inverse 1 at 298 Kelvin is. Here the electrolytic conductivity is given. The molar conductivity is in the question. The concept is molar conductivity and the electrolytic conductivity, that is kappa, is related as kappa into 10 power minus 3 divided by m, or the molar conductivity is equal to kappa into 10 power 3 divided by m. So the 10 power minus 3, 10 power 3 comes from the volume conversion. Here the two relations are given. Here the unit of kappa is in the Siemens meter inverse 1. Then you can use this formula. And kappa unit is Siemens centimeter inverse 1. It is nothing, it is by means of unit conversion. It is in the liter and it is in the ml conversion. Okay, so this is the concept, kappa and lambda. So in this problem, the electrolytic conductivity kappa is given in the unit of Siemens centimeter inverse 1. So you can use this formula. So what is the formula? Kappa is equal to lambda m into, here you can use this formula. The molar conductivity is equal to kappa into 10 power 3 divided by m. What's the given quantity? The kappa. Kappa is equal to 5.76 into 10 power minus 3 Siemens centimeter inverse 1. And the molarity is equal to 0.5. The molar conductivity is equal to 5.76 into 10 power minus 3. This is for kappa. And 1 10 power 3 divided by 0.5. Okay. This minus 3 is cancelled. You get this value. This is equal to 5.76 divided by 0.5. It is equal to 57.6 divided by 5. So this will be 11.52. And the unit is Siemens centimeter square mole inverse. Your answer is D. Question number 5. The electrolyte and the equivalent conductance are given for KCl, KNO3, hydrochloric acid, NaOAC. Calculate the lambda naught value of acetic acid, that is HOAC, using appropriate molar conductance of the electrolytes listed above. Infinite dilution water at 25 degrees Celsius. It is based on the Kohlrausch law. So according to Kohlrausch law, that is lambda infinity of the electrolyte, here the given is acetic acid, is equal to the sum of the constituent ions. That is lambda of the constituent ions. What is that? That is ACO minus plus H plus. So in order to find out the lambda infinity of this electrolyte, you have to sum up the lambda infinity of the H plus ion and the acetate ion. In the given data, the acetate ion is present in the NaOAC. So NaOAC dissociates into ACO and NO plus. So you can write lambda infinity of this acetic acid is equal to lambda infinity of NaOAC. Here the acetate ion is there. Then we have to account the H plus ion. So it is added to the lambda infinity of hydrochloric acid. So the acetate ion and H plus in here. Then you have to subtract the NaCl. So minus lambda infinity of NaCl. Here the NaCl is subtracted. What do you get? The sum of the HO plus and Cl. By substituting this value, what is that? That is 91.0 plus hydrochloric acid, it is 426.2 minus NaCl, it is 126.5. So this is equal to 517 plus 2 minus 126.5. This is equal to 390.7. So our answer is C. Question number 6. The Faraday's constant is defined as 1 Faraday is obtained by 96,500 coulombs. This constant is obtained by the multiplication of 6.023 into 10 power 23 into 1.6021 into 10 to the power of minus 19 coulomb. So this is the charge of the electron and this is the Avogadro number, that is 1 mole. So by multiplication 1 mole of electrons by the charge of the electron, you get this value, that is 96,500 coulomb. The 1 Faraday is the constant value is equal to charge carried by 1 mole of electrons. Your answer is B. Faradays of electricity are required for the following reactions to occur. The ferromanganate ion is converted into Mn2+. By calculating oxidation number in MnO4 minus, it is Mn plus 4 into minus 2 is equal to minus 1, this charge. And the Mn minus 8 is equal to minus 1. Mn is in the plus 7 oxygen state. The oxygen state of manganese is plus 7 here. Here the oxygen state is plus 2. So the oxygen state is converted into plus 2, it is reduced. By writing the equation MnO4 minus plus 5 moles of electron, so that it is converted into Mn2+. Here, for the conversion of this ferromanganate to Mn2+, you need 5 moles of electron. 5 moles of electron is nothing, it is 5 Faraday of the current is needed. So your answer is 5F. Question number 8. A current strength of 3.86 ampere was passed through the molten calcium oxide for 41 minutes and 40 seconds. The mass of calcium in grams deposited at the cathode. The atomic mass of calcium is 40 gram per mole and 1 Faraday is equal to 96,500 coulomb. The concept is, from Faraday's first law, the mass of the substance deposited at the electrode is given by the formula ZI into T. Here Z is electrochemical equivalent and I is the current, T is the time in seconds. And Z is also obtained by the molar mass divided by N into 96,500 coulomb. It is the amount of the substance deposited when 1 coulomb current is applied. Okay. By using this formula, the M is equal to, for Z you can write the molecular mass divided by number of electrons into 96,500 into I is in ampere and T in second. The given data, I is equal to 3.86 ampere and T is equal to 41 minutes, that is 41 into 60 seconds plus 140 seconds. So this is equal to 2460 plus 40, 2500 seconds. Now you apply the molecular mass, that is M is equal to 40, and the number of electrons, the calcium chloride, it dissociate to give Ca2 plus 2Cl minus. Here the number of electrons involved is 2 electron. The M is 40 gram mole inverse divided by 2 into 96,500. I is equal to 3.86 and T is equal to 2500. What are the values you can here cancelled? The one is this 20 and this 20 and the 5, and here you can 193. Again you cancel this, it is 3.8.6. It is cancelled as 10. So this will be 40 divided by 2 into 10, it is 20 is equal to 2. So the answer is B. Question number 9. During electrolysis of molten sodium chloride, the time required to produce 0.1 mole of chlorine gas using a current of 3 ampere is. So in the sodium chloride decomposition, NaCl is dissociated into Na plus and Cl minus. The Cl minus is converted into chlorine gas. So 2 Cl chloride ion plus 2 electron, it is chlorine molecule. The number of electron involved is 2. And this molecular mass of chlorine atomic mass 30, molecular mass is 35.5. So the 2 chlorine 35.2 is equal to 71. So this is a molecular mass. And this problem is based on the Faraday's first law, that is Z m is equal to the mass of the substance deposited is equal to IT. So in this problem, the 1 mole of chlorine gas is using current 3 ampere, and what is the time required? So T is equal to mass deposited Z into I into T. Z, we have known that the molecular formula, the molecular mass divided by number of electron involved into 96,500. Here the molecular mass of the chlorine is 71 divided by number of electrons 2, 96,500. So instead of Z, you can apply this. And what is the M? M is equal to 0.1 mole. So this is equal to 7.1 gram of chlorine is obtained. For 1 mole is 71 and 0.1 mole 7. So T is equal to, the mass is 7.1, and instead of 71, Z you can write 2 into 96,500, and I value, here the I is 3 ampere, 3.7.1 divided by 71, here 2 into 96,000 into 3. So by solving this, you will get 10 here, and here you get 5. Finally, you get 46433 seconds. This is equal to 107.2 minutes. Our answer is B. Question number 10. The number of electrons delivered at the cathode during electrolysis by a current of 1 ampere in 60 seconds. The concept is 1 Faraday, 96,500 coulomb, contains how many number of electrons? That is 6.023 into 10 to the power of 23 electrons. Here the current is 1 ampere and the time is t seconds. The coulomb is calculated by the formula I into t. I is equal to 1 ampere and t is equal to 60 seconds. Totally 60 coulomb of current is passed. The question is number of electrons delivered. You know that 96500 coulomb of current will displace how many number of electrons? That is 6.023 into 10 to the power of 23 electrons. Therefore, 60 coulombs. By cancelling, get is equal to 6.023 into 10 to the power of 23 divided by 9650. Here 16. This can be simplified as 6023 into 10 to the power of 20 into 6 divided by 9650. This is equal to 38 divided by 9650. So this is equal to approximately 3 point something. So 3.75 20. So the answer is C. Okay. The concept is 1 Faraday of electron display 6.023. Therefore 60 coulomb of current. The 60 coulomb is obtained by multiplying 1 ampere into 60. Clear? Question number 11. Which of the following electrolytic solution has the least specific conductance? Concept is the specific conductance and concentrations are directly proportional. That is, concentration increases, specific conductance also increases. Here the question is which of the following electrolytic solution has the least specific conductance? That means the electrolytic solution with the lower concentration, least specific conductance. So our answer is here the 2 normal. Here it is 2 into 10 to the power of minus 3 normal. So it is in the lower concentration. So our answer is B. Question number 12. While charging lead storage battery, the lead sulfate on cathode is reduced. Lead sulfate on anode is oxidized. Lead sulfate on anode is reduced. And the lead sulfate on cathode is oxidized to lead. So in lead storage battery, the EMF value is 2 volt and the anode is lead and the cathode is lead oxide. Here the oxidation occurs in the anode part, so lead is oxidized, and in the cathode part lead oxide is reduced. So this is the basic of the lead storage battery. The EMF is 2 volt, anode is lead, so the oxidation takes place and lead is oxidized to Pb2 plus, and cathode the lead oxide is reduced. In case of charging, the process is reverse. When you apply the voltage higher than 2 volt, what happens? The reaction is reversed. That means in anode, reduction takes place, and in the cathode, oxidation takes place. The process is reverse. Clear? So in this problem, while charging lead storage battery, the process is reversed. So cathode is reduced. Cathode, the oxidation process takes place, so it is not the answer. And anode is oxidized, it is not the answer. And anode is reduced and cathode is oxidized to lead. So this C and D may be the answer. So what is present in the cathode? Cathode is lead oxide. So consider the option C. So it is present, anode is reduced to lead. Okay. So in case of charging, what is that? Pb is oxidized to Bb2 plus. So the reverse process, the Bb2 plus, that is in lead sulfate, it is in the Bb2 plus in anode, correct, and it is reduced to Bb. So this statement is correct. In case of D, the BbSO4. Here the cathode, what is the substance present? That is PbO2. That is in the charger, Pb4 plus is reduced to Pb. So this is wrong statement. So our answer is C. So by means of recharging, the process is reverse one. From that you can decide the answer. Clear? Question number 13. Among the following cells, one is Lagrange, the second one nickel cadmium cells, third one lead storage battery, fourth one mercury cell. The primary cells are. The concept is the primary cell is non-rechargeable, and the secondary cell, it is rechargeable. The Lagrange cell is the primary cell and is non-rechargeable, and a nickel cadmium cell, lead storage battery, and a mercury cell. First one is the Lagrange cell. Lagrange cell is the primary cell. It is non-rechargeable. Nickel cadmium cell and lead storage battery, it is a storage battery, and so it can be recharged. So it is a secondary cell. Lead storage battery is a secondary cell. Only the Lagrange and the mercury cells are primary cell. Your answer is A. Question number 14. Zinc can be coated on iron to produce galvanized iron, but the reverse is not possible. It is because in the electrochemical series, the zinc is having the value zinc reduction potential, that is zinc 2 plus zinc. The reduction potential is given as minus 0.76 volt. The reduction potential of iron is given minus 0.44 volt. So this means the zinc is easily oxidized, and the more negative, more is the negative, easier is the oxidize. So this is subject from electrochemical series. Zinc is more electropositive. When the zinc and Fe solutions are present, what happens? The zinc is easily oxidized, and so the iron sulfate, zinc is reacted. What happens? The zinc is coated on. Zinc is the iron is replaced by zinc because it is easily oxidized to give the +2 ions. So in short, what you have to remember is more is the reduction potential, more is the oxidizing power, more easily oxide, and it has more reducing power. Okay. So from that we can answer this question. Here the zinc is lighter than iron is not answer or answer. And the zinc is lower melting point than, so zinc has lower negative electron potential than iron. It is wrong. Zinc has higher negative electron potential than iron. It's the correct statement. Your answer is D. Question number 15. Assertion. Pure iron when heated in dry air, it is converted with the layer of rust. Reason rust has a composition of Fe3O4. What about the statement and the reason? First of all, the composition of rust is nothing. It is Fe3O4 dot XH2, ferrous oxide, and is the combination. But it is given rust has a composition of Fe3O4, so this reason is wrong. And the pure iron when heated in dry air, it is converted with the layer of rust. For iron rusting, we need moist air, not the heated air. So this statement is also wrong. So both assertion and the reason is the false statement. Your answer is D. Question number 16. In hydrogen-oxygen fuel cell, the reactions occurs at cathode. The concept is the fuel cell, the fuels are combusted, the energy is directly converted into electrical energy. For example, the hydrogen-oxygen fuel cell is represented as hydrogen, nickel, and the electrolyte is KOH, and another electrode is the nickel oxide, and the oxidant is oxygen. So hydrogen is a fuel, and this is the electrode, then electrolyte, then electrode, and finally oxidant. So it is a general representation of the fuel cell. The hydrogen oxygen fuel cell. Hydrogen is a fuel. Okay. And here the hydrogen is oxidized and oxygen is reduced. Oxidation occurs at the anode, reduction occurs at the cathode. Here hydrogen is oxidized, that means H is converted into H plus. The oxidation number is 0, here 1. Oxygen is reduced means oxide is converted into oxygen. Oxygen is reduced means the oxidation number is reduced. Here the oxygen is 0, it is OH, here minus 2 is 0. So reduction. So the reduction reaction of first one, oxygen, here oxidation state is 0, it is negative, so it is reduced. Cathode, the reduction takes place. And here it is oxidized. Hydrogen plus is oxidized to water. And here it is O, and here plus 1, it is oxidized. And here it is reduced. But in cathode, reduction takes place. This one is the correct answer. Yeah. Question number 17. The equivalent conductance of M/36 solution of weak monobasic acid is 6 mole centimeter square equivalent inverse. At the infinite dilution is 400 mole centimeter square equivalent inverse. The dissociation constant of the acid is. The dissociation constant is given by Ka is equal to alpha squared C for the weak electrolyte. And alpha is equal to ratio of this equivalent conductance at particular concentration and equivalent conductance at infinite dilution. Here the given quantity alpha. Even the concentration is M/36, the equivalent conductance is 6 mole centimeter square equivalent inverse. At the infinite dilution, it is 400 mole centimeter square equivalent inverse. So unit is considered. So this is alpha. So Ka is equal to 6 by 400 into 6 by 400 alpha squared, and the concentration is 1 by 36. So the 36 is cancelled, and it will be 1 by 16 into 10 to the power of minus 4. This is equal to 1 by 16 into 10 to the power of minus 4. This is equal to 0.0625 into 10 to the power of minus 4, or it is equal to 6.25 into 10 to the power of minus 6. Your answer is B.
Question number 18. A conductivity cell has been calibrated with a 0.01 m 1:1 electrolytic solution. Specific conductance kappa is equal to 1.25 into 10 power minus 3 Siemens centimeter inverse 1. in the cell, and the measured resistance was 800 ohm at 25 degrees Celsius. The cell constant is, the R is related to specific resistance by L by A, and the rho is 1 by R into A by L, and kappa is equal to 1 by rho. This is equal to R into L by A. Simply we can derive the relation, the kappa is equal to cell constant by resistance. So this is the formula we have to require to solve this problem. Here it is given that the resistance, it is R is equal to 800 ohm, and the concentration is given, it is equal to 0.01 m, and the specific conductance that is given, that is kappa is equal to 1.25 into 10 power minus 3 Siemens centimeter inverse 1. This cell constant is the question. So the relation is cell constant by resistance. So cell constant is equal to kappa into resistance. The kappa is 1.25 into 10 power minus 3, and resistant is 800 ohm. So this is equal to 1000 into 10 power minus 3. The unit of kappa is Siemens centimeter inverse 1. The unit of resistant is ohm, that is ohm. The Siemens and ohm is cancelled. Siemens is the inverse of the ohm, so it is ohm inverse 1, it is ohm, so this cancelled. So it will be 1000 10 power minus 3 is equal to 1 centimeter inverse 1. So the cell constant L by A is equal to 1 centimeter inverse 1. Your answer is?
Question 19. The conductivity of a saturated solution of sparingly soluble salt AB, that is 1:1 electrolyte, at 298 Kelvin is 1.85 into 10 power minus 5 Siemens meter inverse 1. Solubility product of the salt AB at 298 Kelvin. The given electrolyte is AB. We have to find out the calculated of Ksp of the electrolyte AB, solubility product. AB dissociate to give A plus and B minus. The Ksp is equal to concentration of A plus into concentration of B minus. It is a 1:1 electrolyte, so that the concentration of A plus is equal to concentration of A minus. So these are some of the relation. The given data is the kappa value. Kappa is 1.85 into 10 power minus 5 Siemens meter inverse 1, and lambda m, that is molar conductivity, is given. It is equal to 14 into 10 power minus 3 Siemens meter square mole inverse 1. And the relation between specific conductivity and molar conductivity is nothing. The kappa, the molar conductivity, is equal to kappa into 10 power minus 3 divided by the concentration in molarity. So you can find out the concentration using this formula by substituting the values of molar conductivity, 14 into 10 power minus 3 is equal to specific conductivity 1.85 into 10 power minus 5 into 10 power minus 3. This is in the formula divided by concentration. So this concentration is equal to 1.85 into 10 power minus 5 into 10 power minus 3 divided by 14 into 10 power minus 3. Minus 3 minus 3 is cancelled. You get the value 1 point. So it is 1.85. So approximately is 1.32 into 10 power minus 6. So this is the concentration. Now you can calculate the Ksp. What is Ksp? Ksp is equal to the concentration of A plus into concentration of A minus. Both are equal for 1:1. So it is 1.32 into 10 power minus 6 whole square. So the power may be in the 10 power minus 12. So minus 12 is in the all the case, and 1.32 power square root 2 is 1.74. So your answer is D. Question number 20. In the electrochemical cell, zinc sulfate 0.01 m concentration, copper sulfate 1 m concentration copper. The EMF of the Daniell cell is equal to E1 when the concentration of zinc sulfate is changed to 1.0 m and that copper sulfate changed to 0.01 m. The EMF changes to E2. From the above, which of the relation between E1 and E2? The problem, the given cell that consists of zinc sulfate, the concentration is 0.1 m. Salt rich copper sulfate, the concentration is 1.0 m and it is copper. The EMF value is E1. Okay. Then the same cell, the concentration is inverted. Here the concentration is 0.1 m and the copper sulfate, the concentration is 0.01 m. Now it is E2. So what is the relation between E1 and E2? Using Nernst equation we can solve this problem. Nernst equation is used to find out the EMF of the cell at different concentration. The electrochemical cell, the cell reaction is zinc is oxidized and copper is reduced. Cu2 plus zinc 2 plus copper. So writing Nernst equation for this problem, that is E1 is equal to E0 minus 0.0593 divided by the n value. N value is number of electrons. Get the 2 electrons involved. 2 into log concentration of product, that is Zn2 plus divided by concentration of the reactants. So it is E1. Okay. Substituting, what you get? The E0 value minus 0.0593 by 2 into log zinc 2 plus concentration is, that is 1 into 10 power minus 2 and the concentration of copper 2 plus is 1. So this is equal to E0 minus 0.0593 by 2 into log 10 power minus 2 and E1 is equal to E0 minus 0.0593 by 2 into minus 2. So this minus 2 to cancel. Here minus sign is there, it will be plus. So it is E0 plus 0.0593. Then you have to find out the E2 value. What is E2? By substituting, E2 is equal to E0 minus 0.593. The same electrochemical cell, it is 2. Now the zinc concentration is 1 and the copper concentration is 1 into 10 to the power minus 2. So this is equal to E0 minus 0.0593 by 2. Here log 1 into 10 to the power of 2. This is equal to E0 minus 0.0593 by 2 into log 2, it will be plus 2. 2 to cancel. Here the minus sign. So E2 is equal to E0 minus 0.0593. So this is a E12. Here the E1 is obtained by adding 0.0593 to the E0 value. E2 is obtained by subtracting 0.053 from the E0 value. From that value, we can notice that the E1 is greater than E2. Your answer is B. Question number 21. Consider the change in oxidation state of bromine corresponding to different EMF values as shown in the diagram below. BrO4 minus to BrO3 minus 1.82 volt, HBrO to Br2 1.595 volt, Br to Br minus, the EMF value is 1.0652 volt. Then the species undergoing disproportionation reaction is. The given reactions, the various reactions, the BrO4 minus. Here oxidation state of bromine is plus 7, oxidation state of bromine is plus 5, and E1 naught is equal to 1.82 volt given. And the second one, BrO3 minus is converted into HBrO. Here the state is plus 5, here it is plus 1, E2 is equal to given 1.5 volt. The third one, the HBRO is converted into Br2. Here it is plus 1, the bromine is 0, reduced, E3 is equal. And the bromine is converted into Br minus. The E4 value is, it is minus 1, 0. Again it is reduced. Okay. Now the combination of two, that is one oxidation and reduction, it is combined. So this couples one cell, and here it couples one cell, and it is again one cell. Now calculating the E cell, first cell. E cell is equal to E2 minus E1, and another one, E2 cell is equal to E3 minus E2, and E3 cell is equal to E4 minus E3. In the first case, it is E2 is 1.5 minus 1.82. This is equal to minus 0.32 volt. The second case is equal to 1.595 minus 1.5. This is equal to plus 0.095. The third case, 1.065 minus 1.595. This is equal to minus 0.5298. In the first case, the E naught value is negative, and the second case it is positive, and third case is negative. So we know that del G is equal to minus N of E. If E is positive, the reaction is spontaneous. Okay. So the first and the third cell is not spontaneous, and this one is a spontaneous. The second one is a spontaneous. That combination is this one. That is BrO3 minus 2 HBRO and HBRO to Br2. Here the common species is HBRO. This undergoes disproportion reaction. Disproportion is nothing. The same species undergo oxidation as well as reduction in the same process. Okay, so our answer will be HBRO. Question number 22, for the cell reaction is given. The E cell value is given at 298 Kelvin. The standard disk free energy of the cell reaction. Standard free energy is calculated by using the formula del G is equal to minus NF E naught value, E cell. Here the E value is given. E cell is equal to 0.24 volt, and Faraday, you know that F is equal to 965,000, and the unknown quantity is N. For the reaction, you write Fe3 plus is converted into Fe plus 2. With the 2 Fe3 plus ion and 2 Fe. For 1 Fe3 plus 1 electron, so the 2 electron is added. So it's a 2 electron process, hence equal to 2. Similarly, the I minus is converted into I2. So 2 iodide ion gaining electron plus 2 electron, you get iodine. Here it is, it loses electron. So it is a 2 electron process. Del G is equal to minus N is 2, F is 96,500, and the 0.24 volt. By multiplication you get 46320 joule. By converting into kilojoule, it is minus 46.320 kilojoule. So this is a simple multiplication of NFE0. So this is the concept. Del G is equal to minus NFE0, the number of electron involves, and the E cell value. Then you can easily find out the Gibbs free energy level. So it is negative, the reaction is spontaneous one. Question number 23. A certain current liberated 0.504 gram of hydrogen in 2 hours. How many grams of copper can be liberated by the same current flowing for the same time through copper sulfate solution? This problem is based on Faraday's law of electrolysis, law 2. Based on Faraday's law of electrolysis, the weight of substance liberated at the electrode is directly proportional to their equivalent mass. Okay, so mathematically you can write that W1 by E1 is equal to W2 by E2. W1 is the weight of the first substance, E1 is the weight of the equivalent weight of the first substance. Here the hydrogen is given, so weight of first substance hydrogen is 0.54 gram and equal mass of hydrogen is 1.008. Okay, and the weight of the other substance is copper, so this is in question, and the equal mass of the copper is 31.75. How it is calculated? The equal mass of the copper is equal to its atomic weight divided by valency, that is 2. Copper 2 plus. Okay, copper sulfate is copper 2 plus. So atomic weight is divided by the valency. So atomic weight is 63.5 divided by 2. By cancelling you get the W2. It is the weight of the copper W2 is equal to 0.504 into 31.75 divided by 1.008. So it is cancelled by here 2. W2 is equal to 0.504 into 31.75 divided by 1.008, cross multiplication. So it can be cancelled to 31.75 divided by 2. This is equal to 15.8 gram. Your answer is B. Question number 24. A gas X at 1 atmospheric pressure is bubbled through the solution of containing a mixture of 1 My minus and 1 Ms at 25 degrees Celsius. If the reduction potential of X, Y, X in the order, that is Z is greater than Y and Y is greater than X. Given that the order of reduction potential substance is X greater than S greater than Y greater than X. In the electrochemical series, higher reduction potential means it oxidizes other, and lower reduction potential means it reduces other. Higher potential oxidizes other, lower reduces other. So it is the electrochemical series. Here the Z is having strong reduction potential. So Z can oxidizes both Y and X in case of oxidation. In case of reduction, lower reduction potential means it reduces other. In case of reduction potential, they having lower, X can reduce both Y and X. So in case of reduction. Now consider the first one. So it is concluded that having strong reduction potential, having higher reduction potential can oxidize the others. So regarding oxidizing, the Y will oxidize the X. Correct? Y and X is having lower reduction potential than Y. So Y will oxidize X and not Z. So A is your answer. In case of B, Y will oxidize Z. That is wrong. Y will oxidize both X and Z, wrong. And Y will reduce both X. Y will reduce only the Z, not the X. So your answer is A. Question number 25. The cell equation A plus 2B minus gives A2 plus 2B. A2 plus 2 electron gives A. The potential is given, that is plus 0.34 volt. And the log K value is given 15.6. For cell reactions, find E0 for the B plus electron gives B. The given cell equation is A plus 2B minus gives A2 plus 2B. So the cell representation, it is a cell reaction. Cell representation is given by A is oxidized, so A2 plus and B is reduced. That is B plus is reduced into B. E cell is given by E of cathode minus E of anode. Or you can write the E naught value of cathode is E plus bar B minus E Anode is A reducing A2 plus. Okay. The E naught value and equilibrium constant is related as is equal to 0.059 N into log K. Here the number of electrons involved is equal to 2 because A2 plus 2 electrons are involved. By substituting this value, that is E is equal to 0.059 by 2 into 15.6 log K is given. E can be expanded as the potential of E P plus B minus, it is a cathode minus anode, EA plus A is equal to 0.059 by 2 into 15.6. The reduction potential of A2 plus is given. So this is the question. EB plus B minus 0.34 is equal to, this will be cancelled. It is 7.8. 7.8 and this multiplication you will get 0.46. Therefore, EB plus B minus is equal to 0.46 plus 0.34 is equal to 0.80. The answer is A. The reduction potential is nothing. It is a reduction of B plus 2 E. So this here the equation is given. From the cell, you can find out the equation. Okay. Okay, students, we have come to the end of this presentation. I hope that it is useful to you. If any queries regarding this objective type questions, post or comments. Thank you for visiting.